let's connect our previous understanding of one-sided limits to two-sided limits. Remember that one-sided limit is the value the function is approaching as we approach x from the right or from the left, all right? So now we said we have this f of x, which is a function defined for all of the values again in an open interval, right? That contains a. And again, it doesn't really mean that the function is defined at a within that interval. And L is going to be just a real number. Then the limit of that function f of x as x approaches a equals L, if and only if the limit of the function as x approaches a from the left and the limit of the function as x approaches a from the right are both the same value L. All right, this is telling me that as I approach, and again, if we create the picture, if we have x equals a in here, remember that if we go in this direction, we are approaching a from the left. If we go on this direction, we are approaching a from the right. All right, so now this is our line. If the function is approaching the same value from the left and from the right, then the limit of the function when x approaches a exists and it's equal to L. All right, when we do one-side limit, the limit from the left and the limit from the right doesn't necessarily need to be the same. In the case that they are not the same, then we said that the limit of the function as x approaches that particular value doesn't exist. But if the two one-sided limits are the same, then the limit of the function exists. Let's see that in some examples with functions evaluating two-side limits from a graph. So we have this function f of x, all right? And so again, remember our function is just all this. And then we have values where the function is not defined like in the function, but outside of it. We have another case in here where f of -4 is actually -2 and so on. So we are going to work with x equals -2, right? So we need to find letter A is asking us to find a one-side limit. B, it's asking us to find the other one-side limit. And then letter C is asking about the two-side limit, and you see that we have no subscript in here whatsoever. So the limit of the function as x approaches -2 from the left, again, remember that we always have to kind of look where we are making that line. So this is x equals -2. We are approaching from the left, meaning that we're using this part of the curve. And again, we want to look very, very, very close to that x equals 2 value. And the y value for that is going to be -2. So the limit is -2. When we do the right, okay, and again, I'm going to delete all this. For B, we want to approach -2 from the right. So again, this is x equals -2. This is the right. And so when we are approaching and we are very close, the y value for that function is again -2. All right, so then here comes the definition of the two-sided limit. If the limit from the right is the same as the limit from the left, right? So if the limit when x approaches -2 from the left is the same as the limit as x approaches -2 from the right, then the limit of the function when x approaches -2 exists, and it's equal to the same value that we have in here. All right, so in other words, when we're looking at the graph, you look how from the left and from the right, we are coming to the same place, and that place is -2, then that limit exists. All right, so that is the connection between the one side and the two side limit. Let's look at another example. Here we are approaching 4, all right? So we're here. X equals 4 is just right here. So we are talking about what happens when we approach 4 from the left and when we approach 4 from the right. So let's do A. What is the limit of the function when x approaches 4 from the left? Approaching 4 from the left. So this is your 4. This is the left. So this is the piece of the function that we need to look for. This is the point that I'm interested in. And the y value for that is -5. So that is going to be the limit of the function when x approaches 4 from the left. B, what happens when we're approaching 4 from the right? So again, this is your x equals 4. This is approaching from the right, right? So it means that we are paying attention to this graph. So when we pay attention to that, the y value that we are interested in is 1. So then it means that the limit as x approaches 4 from the right is 1. Does the limit exist? No, it doesn't exist because the one-side limits are not the same. So then in here, when we are answering this question, this will be a null response because the limit when x approaches 4 does not exist. All right, again, you see how you are coming in this direction, and then from here you have to jump on to continue. So the limits are different because the function is approaching two different y values from the right and from the left. Another example. Let's evaluate this limit when x approaches 2 from the left, from the right, and if the limit exists. So again, x equal 2 is this. From the left means that we are paying attention to this part of the graph. So at this point, our y value is -5. That's your limit. All right. So again, from the right, x equals 2. That's the value that we're approaching. This is the function, right? We're approaching from the right. So then, as we approach from the right, this is the value that we are interested in. And from here, the y value is 3. So then the limit is going to be 3 when x approaches 2 from the right. Now the question is, does the limit when x approaches 2 exist? Yes or no? Again, they are different, which means that this doesn't exist because when I come from the left, I have to jump on to start from the right, and the two y values are different. All right, continuing on to evaluate limits graphically. Now the one-side limits disappear, and the question is, this is the graph of h of x. We want to use that to find the limit of the function as x approaches 0. So here is my 0. So x is approaching 0, right? Remember that we're going to approach from the left and from the right. Okay, so from the left, we're going to do this. And when x equals 0, the y value is approaching -2. So the limit as x approaches 0 from the left of that function, this is -2. Then we go and see what happens from the right. So again, as we approach 0, remember that we're talking about the axis and approaching 0, the y values are also approaching -2. So we said that the limit as x approaches 0 from the right of h of x is -2. Then again, if the left and the right are the same, then we can say that the limit of the function as x approaches 0 is -2 because it exists because the two side limits coincide. They are the same. All right. Last one here. What is the limit of the function h of x as x approaches -3? So again, this is your -3. Remember, you were talking about x equals -3, this number here. So I am just creating this imaginary vertical line. So from here, this is the left. So this is the function that you're looking at. From here, this is the right. So this is the function that you're looking at. So what happens with here? So you see how this side is approaching y equals 4. And this side is also approaching y equals 4, which means that the limit of h of x as x approaches -3 is 4. Again, it exists because the left is approaching 4, but the right, it's also approaching 4. So that limit exists. Any questions? Just leave them in the comment.